Today we are going to break down the most common protection devices you see in electrical systems, MCB, RCD, RCBO, MCCB and ACB, and I'll explain them in a simple and clear way. We'll also look at things like motorized operation and auxiliary contacts so you understand how these devices work in real installations. Let's start with the basics. The MCB or miniature circuit breaker is the switch plus trip unit breaker you see in homes and small commercial boards. Its job is switching the circuit on and off, protect the circuit from overloads and overheating, protect the circuit from short circuit. It usually works at 230 or 400 volts and it's perfect for lighting and socket circuits. These are MCB symbols you might see on electrical schematic drawings. Next is the RCD, the Residual Current Device. This one protects people if electricity leaks to earth, meaning it's going somewhere unsafe. The RCD trip instantly. It does not protect against overload or short circuit, only leakage. You will see it in bathroom, kitchen and outdoor circuit. Then we have the RCBO. Think of it as an MCB and RCD combined into one device. It protects against overload, short circuit and earth leakage. It's great for individual circuits where you want full protection without using extra space. Here you can see the RCBO symbol. Check out this table for a one-shot comparison of the three devices. MCB rating current is up to 100 or 125 dependent on the brand. RCD trigger current is 30 to 300 milliamps and RCBO rating current is up to 63 amp. Their voltage range is up to 400 and there is no adjustable setting on them. There are also other important devices inside distribution boards or AC panels like SPDs, which stand for Surge Protection Device, phase failure relays, contactors, timers and more. And I'll cover all of those in a separate video. Now let's move into the bigger devices used in industrial systems. The MCCB or Moulded Case Circuit Breaker is like a stronger version of the MCB. It handles higher currents from around 100 amps up to 1600 amps and can work at voltage up to 800 volts. MCCBs can also be fitted with motorized mechanisms, which means you can open and close them remotely. This is useful in factories, large buildings, or anywhere the breaker is part of an automated system. They also use auxiliary contacts, which tell you if the breaker is on, off, or tripped. You can connect these to relays, PLCs or SCADA system for monitoring and control. There are several key details on the MCCB nameplate that we'll cover in an upcoming video. And finally, the ACB, Air Circuit Breaker. This is the main breaker you'll find at the bottom of the large LV panels, data centers and industrial switchgear. ACBs handle very high currents, often up to several thousand amps, and they also work up to 800 volts. Almost all ACBs come with motorized operation built in, so you can open, close and reset them remotely. They also have advanced auxiliary contacts that show open close status, trip cause, spring charged status and more. Many ACBs even support communication systems like Modbus or Ethernet, so they can send detailed information to SCADA or building management systems. An ACB can have a built-in protection relay, or it can work as part of a large protection hierarchy where it's controlled remotely. This table highlights the key differences between MCCBs and ACBs. You can pause the video anytime to examine it more closely. So here's the quick recap. MCB protects against overload and short circuit. RCD protects against earth leakage. RCBO combines MCB and RCD. MCCB, higher rating, adjustable, can be motorized, supports auxiliary contacts. And ACB's main breaker for large systems, fully motorized and advanced monitoring. Each device has its own job, and together they keep electrical systems safe, reliable, and easy to control. If you enjoy simple explanation like this, make sure to subscribe. I'm a master's level electrical engineer based in Dublin with over 10 years of experience in medium voltage system design and substation protection. And this is Exit Power Lab, where I break down electrical engineering, product comparisons, and practical insights. Thanks for watching, and I invite you to check out the other videos for more.